Federal Drive is presented by GEHA, Government Employees Health Association, proudly providing health and dental benefits to federal employees and their families. Visit GEHA.com.
President Trump signed an executive order in March directing an immediate increase in domestic critical mineral production. But directing and doing are two different things. The scientists at Idaho National Labs have been on the front lines of critical mineral extraction for decades, and they've often led the development of new technologies that make that extraction faster, cheaper, and cleaner. Here to discuss how they're supporting the president's direction is Directorate Fellow at INL, Dr. Bob Fox. Dr. Fox, thank you for joining me.
Carrie, thank you for having this conversation with me today.
We're going to talk about critical minerals. The president signed an executive order not too long ago that sort of raised the national conscience about the strategic importance of critical minerals. You work with them every day. Can I ask you to just give us a quick understanding of what these are and why they matter?
Sure. Very important question. And critical minerals and materials are very important. They're metals or they're substances that are used in technologies such as microelectronics or for electricity generation, such as photovoltaics. There are energy critical materials that are all used in power generation. There are critical materials that are important to national homeland security and defense. So there's a list of about 50, and these 50 materials are right now, the supply chain is dominated by China. So we used to mine and refine and manufacture our own critical materials and devices for critical materials, but over time, much of the mining and refining and manufacturing has been offshored to China, and China dominates. And because China dominates many of the supply chains, the manufacturing of these critical materials, it's left a very precarious situation in the supply chain, because when any country then decides to utilize those materials for political goals, they'll start to cut off supplies, and therefore supply chains are disrupted and technologies cannot make it to market, and especially defense platforms, we cannot defend our nation. So that is why the materials are.
That is a hugely helpful background. And so then how are you and the team at Idaho National Labs involved in the critical minerals market?
So Idaho National Lab has separations. It is in our DNA, separations, science, and engineering. We develop new and advanced separations technologies. And we have been doing that ever since 1952, when the Idaho Chemical Processing Plant was developed for the nuclear fuel cycle. But we've carried those technologies and advanced technologies forward into today, and we've made them better, faster, cheaper. We've also developed new separations technologies. And so Idaho National Lab plays a very important part in providing critical materials to the supply chain for the nation, because we develop separations technologies that allow those materials to go into manufacturing processes.
So you're on the science end. There's got to be private companies or public companies that are involved in the mining side of getting these materials. How do you work with your commercial partners?
Yeah, absolutely. So we have several customers. Federal government, Department of Energy, Department of Defense, all have separations needs for critical materials, but also we have private industry. And private industry customers come to us and they have advanced technical problems, and they say, we need to have help separating gallium from bauxite residues. How do we do that? How do we do that better, faster, cheaper, so that we can maintain competitiveness on the market, competitiveness in the rest of the world? And so helping industry with their bottom line is something that we do. And we enjoy it when industry partners come to the National Laboratory and we're able to help them with advanced technologies.
I'm speaking with Dr. Bob Fox. He's a Directorate Fellow at the Idaho National Laboratory. You do science, and I think of science in a lab. I think of mining out in the field. How do you bring the science and the mining together? Do you take the science to them? Do they bring the mining to you?
Well, we look at our job on a daily basis as nothing more than solving problems. We're problem solvers. We look at problems not as problems. We look at problems as challenges and opportunities. And so we bring together skilled practitioners in chemistry, chemical sciences, engineering, chemical engineering, electrochemical engineering, geosciences, and we build multidisciplinary teams that go to industry or go to the government who explain to us what they believe the problems or the challenges are. And our teams then ideate and formulate ideas for how to solve the problem. So we will have a mining company come to us and say, here is an ore, it has uranium in it. How do we better use an in situ methodology to recover the uranium? Here's a mining company that comes to us and says, we have cobalt and arsenic in our ore. How do we capture and recover the cobalt, but sequester the arsenic, which is a toxic material? How do we sequester it in a thermodynamically stable form to where we can just put it right back into the mine from which we dug it? So multiple problems, developing and problem solving and developing advanced technologies to help private and government sponsors.
I know inside the DoD lab structure, they often have cooperative research and development agreements, or CRADAs, with these kind of partners. Is that something that INL does as well?
Yes, absolutely. So the National Lab is open for business, and the method that we do business with sponsors that are not Department of Energy sponsors, so the Department of Defense sponsors and private industry sponsors, the contract vehicles we use are Cooperative Research and Development Agreement. Another one is called Strategic Partnership Project, or SPP. Both of those are contract vehicles. They have different methods and different advantages. And so we work with our sponsors, regardless of who they are, and come up with an agreement contract vehicle that best fits their situation.
Could you give us an example, maybe without naming names, of a project that you're engaged in that's really sort of pushing the front edge of this kind of collaboration?
So yes, we have a CRADA with private industry, and they have mining claims, and the mining claims are an ore body, and the ore body has very high concentrations of rare earths, some of the highest concentrations that we have seen historically, as well as other very important materials, gallium, for example, vanadium, by way of example. And the private industry partner came to us and asked for technology to help them derive the value or extract the materials from that ore body. But they were very conscientious of the fact that they didn't want to do a lot of environmental damage or minimize the environmental damage. And so they stressed very strongly that they wanted next generation technology that was minimally impactful, that was not, the mining practices that would do a lot of damage in the ecosystem, but was next generation and would minimize impact, reduce waste, be very efficient, actually benefit the biosphere, benefit the ecosystem. And so those are the types of challenges that we at the National Laboratory arise to.
That is a fascinating example, trying to mitigate the damage of mining with a green solution. What is on the frontier for you at INL?
So just that, the nation has a need. The nation has a need, and the need is critical materials, and critical materials permeate throughout many next generation technologies, everything from artificial intelligence to electric vehicles to, cloud storage. The cloud is made of metal, and these metals are very important, and they come from the earth. And so to get them, we have to mine them. And we want to mine them in a minimally impactful way. So on our frontier is the development of next generation mining practices that are surgical, minimally impactful. It's not grandpa's way of mining. It is the mining of the materials in a way that is sustainable, environmentally friendly, minimally impactful. And then everything from the mine downstream to the manufacturing process, Idaho National Lab is developing new separations technologies. We're developing advanced manufacturing technologies, all to make things better, faster, cheaper, more environmentally friendly, and consuming less resources. That is what is on our future. That's what we have our sights set on.
Dr. Bob Fox is a Directorate Fellow at the Idaho National Laboratory. Thank you so much for sharing this important work with us today.
Thank you, Terry.
We'll post this interview at federalnewsnetwork.com/Federal Drive. Listen to the Federal Drive on your schedule. Subscribe wherever you get your podcasts.